Last time we discussed the multiplication rule, and we had a special case when they are independent, right? Okay, then today we are going to discuss the last topic in chapter 4. It is the base rule. Let me introduce to you who is the base. Okay, so let me Google base. Yes, here. He is the Thomas Base. He was born in 1701 and died at 60 years old. He suggested the theorem, the rule, about 300 years ago. Very old one and very classical. Right? So today we are going to discuss what is his rule. So yep. If you want, please read the history of the base rule. For the base rule, we have to make a Venn diagram. Always the Venn diagram is based on a rectangle, which was the sample space. And now here, we have many events of the A's. So it has the many. So it has the index of index. It's A1, A2, it's up to AK. So we have a K event of A's, right? They are mutually exclusive. To remember the mutually exclusive, before we made a Venn diagram, it's separated in the two circles, right? It's a totally different, it's a separated. So the all A's are mutually exclusive and exhaustive. We didn't discuss what is exhaustive. Yeah, we just got only the mutually exclusive. But now today, they are exhaustive. Simply, I can make a Venn diagram. Here's the A1, A2, A3 is up to AK. Definitely, they are separated, mutually exclusive. Exhaustive means when we merge them together, it will be same as the sample space. So the event of the A's, they are mutually exclusive. They don't have any common area. But when we put them together, it will be exactly the same as the sample space. Then you can describe they are mutually exclusive and exhaustive. I can give you another example. When I split only the male and female, I have a sample space U, and mutually exclusively, I separate two groups, male and female. When I merge them together, male and female, it will be same as the sample space. Okay? So in this case, it is an example. The K, that is only two. It's only two groups. Okay? Then they are mutually exclusive and exhaustive. So we can explain the base rule is based on that kind of Venn diagram. Basically, we can make a partitions. It's based on the A's, the K A's, and additionally, we have another event, a B. So I can put an event of B here, who are taking statistics, who are taking STAT2503. So if you are here, if you are taking statistics and males, then you are here then. And you are taking statistics and females, then you are here. If you have any friends, if you have any male friends who didn't take statistics yet, they are here. And if you have any female students who is not taking statistics yet, and they are here. It's based on the sample space, right? Yeah. So when I want to explain the base rule, basically we have to make a Venn diagram. It looks like that. Make the partitions with the A's and one event B in the middle. Before the base rule, we have to understand what is the rule of the total probability. Please don't look at this. Don't look at this. And please don't look at the index of that. Please look at the multiplication. Here's the multiplication between the two probabilities. The first one is the probability of A. Yeah, I'm sorry, I erased the index of J. But please focus on the probability of A. Times probability of, actually the second one is a conditional probability. It's a conditional probability of B given A. Have you ever seen this multiplication before? Did you? The multiplication, probability of A times conditional probability of B given A. Who was that? In the general multiplication rule. Let me go up. Let me go up to the, yes, here. The general multiplication rule. In the right-hand side, there is the multiplication. What is this? The joint probability of A and B. So let me go back to the rule of the total probability again. Now I can write the multiplication will be probability of A and B. How? By the general multiplication rule. But we had index of J. So I just put the J here. It's good, right? Yeah, simply we apply the general multiplication rule. The multiplication will be the joint probability. But just before we take the sum, we take the sigma. I just put the sigma. Then index of J, the index of J from 1 to K. Can you remember how did you get the average? How did you get the average? Take that sum up divided by how many? And also, can you remember the notation? I mean the mathematical notations? When we took the sample mean, x bar, we take the sigma of xi's, the index of I from 1 to n, then divided by n. Can you remember the formula for the sample mean, for the average? But already we knew how can we get the sample mean, how can we get the average? Take the sum up, divided by how many? Now in the denominator there was the n. N was the sample size, is how many? The problem was the mathematical notations. The capital sigma, which was the sum. So, actually it was the sum of x1 plus x2 plus x3 plus is up to xn over n. So the notation, I mean the index of I In the sample mean, we use the index of I, but now we use another index of j. It's ij, it's the same thing. We can change the index of I from 1, 2, 3, until the last one, n. So that is the mathematical notations. It's a mathematical, the rules. We just take the sum. We just take the sum, but every single case, we can change the index. Same thing. It is the same thing. Now, here, we have an index of j. We are going to take the sum. But every single time, the index of j started from 1. Next one, 2. The next one, 3. The next one, next one, next one. And the last one will be k. So now I can expand. Now I can expand the summation. It will be probability of A1 and B plus probability of A2 and B. I just replace it one by one. And the next one is a probability A3 and B. And simply just keep going until probability of AK and B. Does it make sense? Right? No? Please try to understand the notations in the sample mean. And without the formula, please remind how did you get the average? Yeah, it's basically we just take the sum divided by n. That was the basic idea to get the average. But we are using the mathematical symbols, right? Yeah. It is the sum over n, and the sum looks like that. And the rule is take the sum, but every single time we change the index of I, 1 to k, 1 to n, right? Yeah. So now let me think one by one. The very first one, A1 and B. A1 and B. Sorry, just a second. A1 and B. Where is the A1 and B? And ono 된다는 그래? And was in the middle. So A1 and B in the middle, right? So the very first probability from here, the yellow one. Does it make sense, right? And the next one, A2 and B. A2 and B. Where is the A2 and B? Again, in the middle, the common area. I mean here. The second term, the probability A2 and B, that is the second common area. When I take the third one, A3 and B, in the middle, right? So when I take the probability A3 and B, that is here. Next one will be here. And next one will be there. Next one will be there. Next one will be there. Who will be the last one? AK and B. That must be the last one. It's good, right? Then what? Take the sum. Take the sum. Who will be? Simply just probability B. It will be simply the probability of B. When we take the sum, the total probability, it will be the probability of the B. It's good, right? Yeah. So the title has the rule of the total probabilities. Of whom? Of B. Piece by piece, A and B, A2 and B, A3 and B, piece, total probability, that will be the probability of B. Yeah, it is the rule of the total probability. Good, right? Yeah, so at the beginning, yeah, it looks very ugly, it's complicated, but it's nothing. It is nothing. Already we knew what was the general multiplication rule. So the multiplication will be the joint probability, the joint one, right? It's for each piece by piece, right? And sum up the total probability, that would be same as the probability of B. But it is not the base rule. We need the rule of the total probability or the base rule later. But please understand what is the rule of the total probability. It is the probability for the B, just the B, piece by piece. Okay, now then, base rule. Worse. It's worse. About 300 years ago, Bayes suggested us the base rule. Yeah, it looks ugly. Don't look at the left-hand side. And don't look at the, let me look at the denominator first. Please look at the denominator in the base rule. Summation. Yes.
What was the name of the last one?
Huh?
What was the last one?
The previous one? The rule of the total probability. Here. It was the rule of the total probability. The total probability for B. Good, right? Okay. Let me go back to the base rule. And now, please look at the denominator. The capital sigma in math, it is the sum. Sum of the probability of AJ times the probability of B given AJ. Have you ever seen this sum before? Just before. Who was it? It was in the right-hand side in the rule of the total probability. Remember this? I'll show you. Here. The sum of probability of AJ times conditional probability of B given AJ. Exactly the sum of the multiplication is in the denominator. So now I can say it is just the probability of B. By what? By the rule of total probability. We just got it. We just got the denominator, the sum, just before. Then now, I wanna see one by one. Now, let me look at the numerator. Please look at the numerator, the upper one. It is a multiplication. Probability of A. Oh, now it has the index of I, but please ignore the index of I. It is a probability of A times probability of the conditional probability of B given A. Probability of A times conditional probability of B given A. Have you ever seen that kind of multiplication before? Multiplication. We had two kinds of the multiplications, right? One was the general one, and the other one was the special one. Who is this? The general multiplication rule. In the general multiplication rule, again, yeah, we used that before in the rule of the total probability. In the right-hand side, of the general multiplication rule, there was the multiplication. Probability of A times conditional probability of B given A was equal to, who was in the left-hand side? The joint probability A and B, right? So now I can rewrite the numerator will be probability A and B again. How? By the general multiplication rule. Don't forget index of I. By the two rules, we can rewrite the fraction in the right-hand side in the base rule. It will be same as the probability of A and B over the probability of B. The fraction of the two probabilities. The joint probability over the marginal just a second. Joint probability over the marginal probability. Have you ever seen that before? The joint probability of A and B over the marginal probability of B. Please remind the conditional probability. Let me go up again. Conditional probability. Yes, here. The conditional probability. A and B over the marginal probability of just A. Who was that? In the left-hand side, B given A. Finally, we can apply the conditional probability rule. It will be A given B. But don't forget the index of I. Yeah, still just keep I. Now it is. So from here, from here to here, by what? By the conditional probability rule. We applied is almost every single rules we got before onto the base rule. So whenever we need a probability, when we need a probability A given B, please remember the order. The probability A given B. We can apply the base rule by the unconditional probability of A times the conditional probability of B given A, the switched one. right? Yeah. So let me give an example. I can show you this one later, okay? Yeah, look at this. Yeah, please read it. First of all, we have to make the Venn diagram. How many partitions? I mean, how many A's? What is the K? Mutually exclusive and exhaustive. How many? I just give you the A1 and A2 here. What is the A1? Event, the group who has the lung disease. And here is the A2. Sorry, no lung disease, and A2 is the lung disease, right? So I can separate the two groups. A1, no lung disease. A2, the lung disease. They are mutually exclusive and exhaustive. What is the event of B? Additionally, we need the event of B. What is the event of B? It is the smoking. Smoke. Who are there? Who are here? I'm smoking and no lung disease. Fortunately, even though I'm smoking, I don't have a lung disease yet. Who is here? Smoking and who has a lung disease? Right? Yeah. Why not? And here, it's most of you. I'm not smoking and I don't have a lung disease. Why not? Who is here then? I'm so sorry. You're not smoking, but some other reason you have the lung disease. So can you understand the case by case, right? Yeah. Also, let me make the tree. Just a second. Can I make the 2 pages? Yeah, it's good. It's not only the Venn diagram, but also let me make the tree. You know, last class, we made a tree. So the very beginning, we have 2 groups, A1, A2. Who was the A1? No lung disease. And the A2 is lung disease. And then we can split. It's a B and not B. What was the B? Smoke. It's a non-smoke. Smoke. And it's not B, non-smoke. So here is the A1, no lung disease, and smoke. No lung disease and not smoke. A2, lung disease and smoke. And this one is the lung disease, but it's not smoke. We can split, we can make the tree case by case. Additionally, we put the probabilities. Can you tell me what is the proportion who has the no lung disease or even the lung disease? Please read example 4.26 carefully. According to the chapter, 7% has a lung disease. Then number one, number two, which one is a 7%? Huh? What is 18? A2, thank you, yeah, A2, yes, second one. Second one is the 7%, 0.07. Then can you tell me the first one, the yellow one? How did you get 0.93? Because we knew, how much was the sum? We knew the sum was 100%. But the other probability, the proportion who does not have the lung disease was not given. But we can figure out. It's only based on the 7% who has the lung disease. The other one must be 0.93. Thank you. And look at the next one, 90%. Which one is the 90%? You know the second column is a B, not B. B is not B. Number 1, 2, 3, 4. 90%. Which one is the probability? Number 1, 2, 3, 4. What? Number 3, why? Among the patients, of those who having the lung disease, who has the lung disease, 90% smoke. So the second probability, 90%, 0.9, must be go here. Does it make sense, right? Among the patients who has a lung disease, 90% they are smoking. So the 90% is must be there, 0.9. And how about the next one? 25.3%. Now we have three other probabilities, number 1, 2, and 4. And the last probability, the given last probability, 25.3%, which one? 1, 2, or 4? 1, let me see. The semicolon of those who not having lung disease. Among the people who does not have the lung disease, what percentage is smoking? That is the 0.235. Yes. The very first one will be 0.253. Can you give me the last one? You know the last probability, the yellow one here? It is not given, right? But can you give it to me? 0.1. How did you get 0.1? We have another 100% here. So the last one must be 0.1. How about this one? Yes. Thank you. We knew that is the other 100%. So the second probability will be 0.747. And the last column is A1 and B, A1 and not B, and just simply take a multiplication. Yeah, we simply apply the general multiplication. Yeah, and we do that. Then now I told you that is the probability of A, and the second one is the conditional probability of B given A. But we have many A's, right? So let me say it's a AJ and AJ is there. But now the index of J can be 1 or 2. A1, no lung disease. A2, the patient who has the lung disease. So can you make the Venn diagram or the tree diagram? Good, thank you. Now, if I'm smoking, it's actually I'm not, but if I'm smoking, I didn't get any. I didn't see doctors yet. But every single time I'm smoking, I'm concerned if I have the lung disease, right? So I want to know the probability. I want to know the chance if I have the lung disease. A2. It's a lung disease. It's actually I need the probability A2 given B. I told you always A2 given B. We have to apply the base rule. Now let me apply the base rule. Then it will be probability of A2 times probability of B given A2 and probability of A2, A1 times probability of B given A1 add probability of A2 times probability of B given A2. Simply I just apply the base rule. By the base rule, we can take the fraction of the multiplication. Now we can plug the probabilities one by one. Did you know how much is the probability of A2? Probability of A2, 0.07. 0.07. The probability of A2, that is a 0.07. And how about the B given A2? Which one is the B given A2 from the tree diagram? B given A2. B given A2. Which one? .9, thank you, yes. The 0.9, that is 0.9, that is the conditional probability B given A2. And this one was here. Okay, now, probability of A1. Probability of A1. Probability of A1. 0.93. Can you say what is the conditional probability of B given A1? B given A1? 0.253. Thank you. Yes. And now the second multiplication will be same as point probability of the A2 and the conditional probability of B given A2. Already we got them in the numerator. It's a 0.07 times, it's a 0.9. Can you give me the multiplication 0.07 times 0.9, please? Thank you. 0.063. And the second probability will be same as the numerator, 0.063. And can you take another multiplication, 0.93 times 0.253? 0.93 times 0.253. 0.2235. 235 and what?
29.
Okay, just take the 235. Can you give me the denominator? You know the numerator is a 0.063. And please take the sum. 0.298. Finally, take the ratio, please. 0.063 over 0.298. Yeah, it is a long calculation, but after apply the base rule, and you can take piece by piece carefully, right? And finally, please take the fraction. How much will be? 0.2, 1, and 1. Finally, what is the probability? When I'm smoking, that is the chance I will have the lung disease. It's more than 21%. Okay. So always we need a probability A given B. We can apply the base rule, right? Yeah. Already I posted the homework, so please do more practice. And now here is the quiz number 9. You don't have to prepare the clean paper. Please do the quiz number 9 on the quiz number 8, because it is the same problem. Anybody who didn't get back the quiz number 8, yeah, please let me know. Last name? You can do the quiz number 9 on the quiz number 8. Last name? Anybody else? Okay. Look at this. Before we had the probability trees diagram in quiz 8, which was the high risk and medium and the low, and we had an accident as a no accident, and no accident, and no accident. And I assigned A1, A2, A3, B, not B, B, not B, and B, not B. Did you get them in the tree? And additionally, we plug the probabilities 0.2, 0.3, 0.5. How much was the first one? 0.25. Then the second one must be 0.75. And how much was the third one? 0.16. Then 0.94. And the next one? Huh?
No, the second one that you just did to the 0.16 should be 84.
Oh, the third one is 84?
No.
Oh, yeah. And that is 84. And then next one?
0.1.
Just 0.1? 10 and 0.90. And then we got the 0.2 times 0.25, 0.2 times is 0.75, 0.3 times is 0.16, and 0.3 times is 0.84, and 0.5 times is 0.10, and 0.5 times is 0.9. Okay, it was quiz number 8. Now, what do I need? I need the probability. It is the quiz number 9. We need the probability. High risk, A1 given B. Now we have a customer. Now we had a customer who had an accident. But I don't know if he or she is high risk, medium risk, or the low risk. But I need the chance, I need the probability. The driver is in the high risk. Okay? Then now, yeah, it is the order. Its order is the A given B. We must apply the base rule, which will be same as the probability of A1 times probability of B given A1. Then in the denominator is the A1 probability B given A1 plus A2 times B given A2 probability of A3 times probability of B given A3. So please plug the probabilities one by one from the tree. First of all, how much is the probability of A1? A1, just A1. 0.2. 0.2. Probability of A2, 0.3. Probability of A3, 0.5. It's good, right? And the second probability, the B given A1. How much is the B given A1? You know, I told you the first column, that is the probability of A, and the second column is the probability of B given A. So now I can plug is a 0.2 times 0.25. 0.2 times is 0.25 again, and the next one is a 0.3 times the conditional probability, and 0.5 times the conditional probability. Think about that, the conditional probability. Anybody who take the B given A2?
0.04.
No.
Oh.
B given A2.
Oh, 0.16, sorry.
0.16, yes. It is a 0.16. Then how about this? B given A3.
110.
Say again?
110.
0.10. Thank you. We can look for the probabilities from the tree diagram and plug into the base rule. And we had multiplications 3 times and summation in the denominator. And finally, take a fraction. That will be the switch as a conditional probability. Yeah, it takes longer time, but plug is 1 by 1. Yes. Oh, yes, you're right. Good job, good job. You know? Um, that is 33.8%, not 3.0. Yeah, yeah.
Oh, question.
Yes.
Is this what it's supposed to be?
No. See, can you try this one again? 22 times 0.25. That is a point 0.05. See, one day I told you, any kind of probability must be less than 1.
Oh, yeah.
Remember that? Thank you. That is the bottom. That is the denominator. Divided by only 1, 2, 4. It is. And the top one is a point 1. Try. Good. Thank you. Yes.
Is that right, or is this?
No.
Is that a different number? I think it's.
Let me. 0.2 times 0.25 is 0.05, and then first one is 0.05, and next one is 0.3 times 0.16. Can we put, yeah, 0.04, good. And the last one is 0.5 times 0.1. It is 0.05. 0.05. So let me take the 0.05, and the second one is 0.08, and the last one is another 0.5. So the denominator will be 0.148. And then take everything. And then will be your last. Doesn't matter. You have to say, 0.338.
You like did like an 8 and you're like,
Wow.
Wow, I'm sorry. Yeah, it's fine.
Okay, it's not my fault, it's wrong, people
That's
to
wrong.
the problem.
Yeah. 0.347 would be good.
Jump on, let's start. I have like 2 packages of them, and I like 4 more packages, I get 2 anyway.
Have a good day. I trust you.
Why don't you